I said it the other day, but I'll just say it again, that this is the stuff from, like, this was from P2, okay, which was the exponents. Obviously, you want to practice your exponents, both positive and negative, dealing with the fractions on the inside. These you can also review from your quiz and from your test because they were on both. Then came the factoring completely. So this was from P4. And I think there's just the one question that is a flat out factor completely, but it is going to have multiple levels. So you're going to have to factor, and then you're going to have to factor again, okay? And that's on the open-ended portion. So you got to be really careful with that because it's not like you're going to be able to compare it with your multiple choice questions to see what you're missing. Okay, so 46, you actually have two options. One is move the things inside the parentheses that have the negative and then distribute the negative on the outside, or flip the whole thing on the inside. All that changes is the outside though. So that is actually how I do it. I would flip it first. So I would do 2a squared b to the negative fourth goes to the top, and a b to the second c to the negative third goes to the bottom. The only thing that changes is the exponent on the outside though. So be careful because you can't change the signs on the ones on the inside and the one on the outside. It's one or the other. Then I would distribute that exponent, and that exponent goes to every term in here. So this becomes 2 to the second, a to the second raised to the second, b to the negative fourth raised to the second, and all of that goes over, a to the second, b to the second raised to the second, and c to the negative third raised to the second. So that exponent went to each term inside. So the 2 to the second becomes 4. Every exponent that's raised to an exponent, you multiply the exponents. So this becomes a to the fourth. Negative 4 raised to the second would be b to the negative eighth over a to the second, b to the second raised to the second. Again, multiply those exponents, b to the fourth. And c to the negative third raised to the second. Again, multiply c to the negative sixth. Then I want to move everything that has a negative exponent. So the 4 stays, the a to the fourth stays, the a squared stays, the b to the fourth stays, but the b to the negative eighth goes to the bottom, and the c to the negative sixth goes to the top. I have an a in the top and an a in the bottom, so I subtract the smaller exponent from the larger one. So this is gone. I'd subtract 2 from here. The 4 is still in the front, but then it becomes a squared, c to the sixth, and then I have 2 b's in the bottom. When we multiply, we add the exponents, so that becomes b to the 12th. All right, how about page 2? So at the top, we continue with the factor by grouping, which was P4. And then underneath, this was mostly, well, this is P3, which was multiplying. That's one of the special products because that was the opposites. The other special product I would say you want to review is like 2y plus 7 squared, okay? The goal would be, it would be fantastic if at no point, if you got a question like that, I saw 4y squared plus 49. Like if we could get past that point, that would be fantastic. You cannot distribute the exponent on a binomial, something that's added or subtracted. All right, then the rest of this was all P5. So you're either factoring to simplify, you are keep changing flip, or you are, well, that's all that on this page. And then it got into adding and subtracting. Maria?
Can you do number 82?
Sure. Oh, yeah, and then this was adding and subtracting. So 1 over x plus 2 plus 1 over x squared minus 4 minus 2 over x squared minus x minus 2. All right, 82. So the first thing you want to do, and I would say be really, really careful with this because it's going to mix together the multiplication, the division, the addition, and the subtraction. So pay attention because obviously depending on what that is, you do it a completely different way. This is addition and subtraction. So the first thing I would do for any of those is factor my denominators. So this would be x plus 2 and x minus 2, and then that one's gone. And this would be x minus 2 and x plus 1, and then that's gone. Because this is addition and subtraction, I need to find a least common denominator. So I'm going to list out any of the factors there that are unique. So x plus 2 comes first. In the second fraction, you have an x plus 2 again, but it's also raised to the first power, so I don't need to add it because I already have it. But I newly have the x minus 2 in that second one. And then I'm going to go to the third one, and I have an x minus 2, which I already have. But I also now have an x plus 1, which means the least common denominator is all three of those things. So I can go through this step of saying 1 over x plus 2 equals what over, and then give the whole denominator. Or I can simply go to each one and say whatever's missing from the bottom of that fraction to the least common denominator is what I'm going to multiply the numerator by. So for the first one, you're missing your x minus 2 and your x plus 1. And then I'm going to go back and distribute that out in a minute. On the second one, if I were to compare the denominator to my least common denominator, I'm missing the x plus 1. And on the third one, if I compare the denominator to the least common denominator, I'm missing the x plus 2. So all of them are going to go over the least common denominator, but I'm going to multiply them out individually. This first one, 1 times x minus 2 times x minus 1 would become x minus, let me change the color, x minus 2 and x plus 1, and then I have to FOIL this out. X squared plus x minus 2x minus 2, which is x squared minus x minus 2. And that's the numerator of the first one. Then I take the sign from in between, which is a plus, and I go to the next one. On the next one, I have 1 times x plus 1, which is just x plus 1. So that's going to go where the second one should go. And then I have a minus in between here, and that's important because it's going to change the sign of anything that comes after it. So then I go to that third numerator, and I would distribute that 2 times x plus 2, and I'd get 2x plus 4. And all of that is going over my least common denominator. Good so far? Yeah, okay. Now I'm going to distribute the negative sign. And then it's all going to go over the denominator, and then I'm going to combine my like terms. So x squared is the only squared. I've got negative x plus x, those cancel out, minus 2x, which means this would be negative 2x. And then I've got negative 2 and negative 4, which is negative 6. And all of that goes over my whole least common denominator, which is x plus 2, x minus 2, and x plus 1. So if this is multiple choice, I would stop there. I would check my answers and see if that is an option. And then you'd notice stop. If it was open, if it's not there, or if it's open-ended, then I would just do the last step, which would be to check to see if you can factor the numerator. There are no factors of negative 6 that sum to negative 2, because it would be 1 and negative 6, 2 and negative 3. None of those add to negative 2. So that is the overall answer at the end. Valerie? Hang on just a second. Are you good on that, Maria?
Yes.
Yeah, okay. 72. All right, so now we're simplifying our rational expressions. We want to factor the numerator and the denominators and see what can cancel out. In the numerator, they all have an x, so that's my greatest common factor. I take an x out, and I get x squared plus 2x plus 3 over x. And then the x's cancel, and I get x squared plus 2x plus 3. There are no factors of positive 3 that sum to 2. If it was negative 3, I could factor this. But there's no factors of positive 3 that sum to 2, which means that's my answer. Other questions on this page? Yeah.
So for 72, if it was like on the numerator, if it was x plus x squared plus 2x plus 3, you can't cancel it out, but it's part of a sum.
You can't cancel if it was only, so you can actually cancel, like I could have done this because they all have 1. I can just do it that way. It would be x squared plus 2x plus 3, so same answer. You just want to get in the habit of factoring it out because it won't always all have the same thing. Yeah. 73. You didn't do 73.
Here.
It is. It's not on there because it's an odd, so the odds are on the answers. Yeah, this is just foiling. So square root of x times square root of x would just be x. And then obviously 1 times 2 is 2. Square root of x times negative 1 is minus square root x. 1 times 2 square root x would be positive 2 square root x. And 1 times negative 1 is negative 1. And then these are like terms. So I get 2x. I add a negative 1 and a positive 2, and I get positive 1 square root x minus 1. So the odds are on, that's why they're not on there. The odds are on chat. The link that has all the odd answers. Other questions on this page? Look, I just realized this I did in this earlier. This is negative 2. I didn't add the 1. That should have been negative 1 minus. I thought it was different. So this should have been a 5. Okay. 84. Okay, so your complex fraction. So you have 2 choices. One is find the least common denominator in my numerator, and then the least common denominator in my denominator, and then keep, change, flip. Or find the least common denominator of all 4 multiplied out. Because the denominator would be the same in the top and the bottom, I think the second method is easier. So I'm going to figure out that my least common denominator would be x, and then x plus 1. Those are 2 different terms. And then I would multiply that x and the x plus 1 times each of the 4 terms that are in my complex fraction. So from the first one, the x's cross out, and I get x plus 1 times 1, which is x plus 1. I take the minus from in between. In the second fraction, the x plus 1's cancel, and I'd get 1 times x, which is just x. That goes over. In the bottom, the first one, the x's cancel, and I get x plus 1 times 1, which is x plus 1. Take the plus from the middle. The x plus 1's cancel. 1 times x is just x. Now I combine my like terms. The x and the negative x are going to cancel in my numerator. I have just 1 in the top. And the x and x add together in the denominator, 2x plus 1. And then that can't get simplified any further, so that's my answer. All right, 90 at the top is your rationalizing your denominator because it has a square root in it. Questions on that one? All right, so we've got our fraction, and you've got a square root in the bottom. If it was a solo square root, if it was just square root 3 or square root 2, I'd multiply top and the bottom by square root 2, but because it's an expression, I have to multiply by its opposite. So 3 plus square root 2, and whatever you do to the bottom, you have to do to the top, so we're going to multiply both. In my numerator, I get 14 times 3, which is 42, and then 14 times root 2, which is 14 root 2. In the denominator, you can use your shortcut. You could either FOIL that out, or you can use your shortcut, which is square the first one, square the second one, put a minus between them. So this is 9 minus 2, which is 7. And then this time, 7 goes into both of these. So 7 goes into itself once, 42 6 times, and 14 twice. So I get 6 plus 2 root 2. Couldn't have done that if it said 42 plus 5 root 2 over 7. That can't be simplified unless you break it apart in 2 fractions. Sometimes on standardized tests you'll see that. Like 42 over 7 plus 5 root 2 over 7. And then this becomes 6. But if it's open-ended, you don't need to do that. Yeah. Only if it goes into all 3 parts. 5 at the bottom. This is what, I mean, it's not like you're never going to see that stuff again, but it's not on the test that are just like the numeric values, so you don't have to worry about that one. And I said you can go up until like cancel the next. This one don't worry about. But we resumed with 8. So they're back to P3. This is your polynomials. Adding, subtracting, and multiplying. Questions on any of those? All right, so x squared over x squared minus 4 minus x plus 1 over x plus 2. All right, so I have to find a least common denominator. I'm going to factor that first one. This is the difference of 2 squares, x plus 2, x minus 2. And then my least common denominator is x plus 2 and x minus 2. The x plus 2 repeats, but the exponent's the same, so I keep it. So my first fraction, I don't have to change at all because it already has that denominator. So x squared stays as x squared. The second fraction doesn't have the x minus 2. So I'm going to have to multiply that out. So here's another scenario where a really easy mistake to make is to forget about this negative. That negative is going to have to get applied to whatever the product of those two are. So I FOIL first and then distribute the negative. So to FOIL x plus 1 and x minus 2, I do first x times x is x squared. I do x times negative 2, negative 2x, positive 1 times x, positive x, and positive 1, negative 2, negative 2. And then combine these like terms, x squared minus x minus 2. So that's the result of this whole product. So my numerator, all of this has to go over the denominator, but my numerator is x squared minus that over the denominator, which means the negative goes to both, or all 3. It would be x squared minus x squared plus x plus 2. Again, all over the denominator. These are going to cancel, and I get x plus 2 over my denominator, which is x plus 2 and x minus 2. And then the x plus 2's actually cancel. It doesn't leave 0 on the top, it leaves a 1. So this would be 1 over x minus 2. So just be really, really careful, especially with your signs there. It's really easy to miss that negative. Any other questions from this page? Yeah, Phyllis. 10B, is that what you said? D. Oh, that's the next page. Hang on. Okay, at the top, this is from the P5. That's your complex fractions. Good morning. P3 here. Any questions on either of those? All right. Questions before I get into, like, I have an interactive review that we can do, but any questions on that PDF before we move on? Going once. Yeah.
I don't know how to do this. I just want to make sure I'm doing it right.
All right, I'm going to rewrite it down here. Y over x minus x over y over 1 over y minus 1 over x. Okay, so your complex fraction. Again, 2 choices. Combine together your numerator and then combine together your denominator, keep, change, flip, or do the same least common denominator for the whole thing. Because the numerator or the denominator would be the same for the numerator and the denominator, I think it's easier to do that second one. So I would multiply everything by xy because that's your least common denominator. So it's going to get multiplied by the first fraction, the second fraction, the bottom 2 fractions. From the first one, the x's are going to cancel, and I end up with y times y, which is y squared. The minus comes from in between. The second one, I would cancel the y's, and I get x times x, so x squared, over. The bottom left one, the y's cancel, and I get x times 1, which is x. Take the sign from the middle. And then the x and the x cancel, and it's 1 times y, which is y. So at this point, if this is multiple choice, I would look at my answer choices, and I would see if that's there. And it's not going to be there because this can factor further. That numerator is the difference of two squares. They're both perfect squares. There's a minus between. So if I factor it, it's y plus x and y minus x. And then over x minus y. And here are your opposites. Same terms with a minus between, but the reverse order, which means a negative comes here. So the answer will either be written as negative y plus x like that, or negative y minus x. If it's open-ended, either of those is good. If it's multiple choice, you're only going to see one or the other. Sure. This was the one that like literally was red, okay? It was missed the most. The first, it just says the expression is equivalent to, and you're subtracting here. So I'm going to factor the second denominator. That would be y plus 5 and y minus 5, which means my least common denominator is y minus 5 and y plus 5. The first fraction is missing the plus. So it would be 6 times y plus 5, and then the minus is in between, minus, and that minus is going to change the sign of everything after. So you can either distribute it then, or put those parentheses around to remind yourself you're going to distribute it. All of that would go over the denominator. Then I distribute the 6, so I get 6y plus 30. The minus gets distributed, minus y minus 5, again over the whole least common denominator. And then 6y minus y is 5y, 30 minus 5 is positive 25. That goes over the whole thing, and that can get factored. 5 comes out, and it'll be y plus 5 over y plus 5, y minus 5. The pluses cancel out, and my answer would be 5 over y minus 5. This is like a perfect example of when you got to here, like when I got to that answer, if I looked at my answer choices, it's the benefit of the multiple choice. It's not there, which is like your little sign that you're going to have to keep going. For these, so like this first one, this is division. And I'll be honest, they're not going to be written as, like, it won't be written as a stacked fraction like that for dividing. It will have the division sign in between. But you're going to have to rewrite it. So I would do z squared. And then I would flip the second one. And then factors. So that top one, factors of 27, that's some to 12 would be 3 and 9. Factor, and that's gone. Factor the bottom one, factors of 36, that's 7 to 13. 4, that's a z, yeah. 4 and 9. Top right, z plus 4, z plus 2. Gentlemen. Bottom right, z, and then z plus 3. And then comes the canceling, the z plus 3s, the z plus 9s, the z plus 4s. All that's left is that z plus 2. Over z. Yes, sorry, over z. There's a z in there. Z plus 2 over z. This one, b. Under that is multiplying. So again, we're factoring. This would be k plus 4 and k plus 8. This would be k plus 8 and k plus 5. This would be k times k plus 5. And this would be k plus 2 and k plus 4. Then we cancel the k plus 4s, the k plus 8s, the k plus 5s, and you're left with k over k plus 2. If I have time after I get through the other ones. Okay. On the right, you've got to factor again. This time, you could do first times last with this one. So 6 times 2 would be 12. Factors of 12 that sum to -7 would be -3 and -4. So I'm going to factor that over here. I'd get 6r squared minus 3r minus 4r plus 2. And then I'm going to factor by grouping. Take out a 3r, it'd be 2r minus 1. Take out a negative 2, it'd be 2r minus 1. And then that's 2r minus 1 and 3r minus 2. That would be the top left one.
Oh, never mind. You don't have to go over there.
Okay. Bottom left, can't factor. Top right, can't factor. Bottom right, you could take out a 5. And it's 3r minus 2. So then the 3r minus 2's cancel, and the 2r minus 1 cancels, and you have 4 over 5 left, which is B. And then this last one is division. I'm going to do keep, change, and flip. And remember, I recommend doing it before you factor because sometimes you tend to do the factoring and you forget about the flipping. Write them as x's and then take it back. So this should have been s times s minus 2. Factor that out. This is s plus 5s minus 2. Factored out. And then you can cancel s plus 5 and s plus 5 and s minus 2 and s minus 2. And what's left is the s over the s minus the 5, which is C. All right, so we only have about 5 minutes left. I'm not going to start the other quizzes, but I will tell you that I'll put on the assignment for the review, like a quiz is for the complex fractions, a quiz is for the negative exponents, a quiz is for factoring completely. So you have to decide like where it is you need the practice. I would say based on yesterday, if I could give you a little bit of feedback, those complex fractions were a little bit rough. So maybe, and it's only 6 questions, that quiz is, so maybe do that one. You don't have to submit anything. This is completely for your review, but you've got to be able to be like, okay, I'm ready to go, or I need to do the extra review because I'm not going to tell you, you know. I would say no one is 100% ready as of now. You need to do some sort of review tonight. It's just individually you have to figure out what it is you have to review. But I will put all those links on the review assignment itself. Once I get through the day, I'll assign them all and then I'll put them all on there, okay? But I would say most of you need practice with complex fractions. And then from there, you've got to figure it out. Do you need it with the factoring? Do you need it with the negative exponents? Do you need it with the rest of that stuff? All of it will be on that assignment.